We are Group 1070, Wireless Power Transfer. My name is Jonathan. I'm here with Devontae and Haltian, and we're going to demonstrate our senior design project. Our advisor and our sponsor are Dr. Noah Torrey of the ECE department. Our problem statement was to build, design and prototype a wireless charger to demonstrate the properties of wireless power transfer. So now we're going to dive into a little bit of what wireless power transfer is and how it works.
So wireless power transfer is the idea of having power transferred from one device to another without having to have a direct connection between the two. The way that is done, or the way that is achieved, is through something called magnetic induction, which is the process of having one coil, which we can see down here, one coil sending a magnetic or an alternating magnetic signal through another coil, which we will be able to measure and see change in voltage whenever this process occurs.
So we have two parts to our design. We have the controller side, and then we have our transmitter circuit side. So now we're going to dive into our controller side and what that is made up of.
The controller is the Raspberry Pi Pico, and for device detection we have a proximity sensor here. It's an IR proximity sensor set to detect at 2 centimeters, and when a device is placed, it will notify charging with a green LED and turn on the relay right here to start the power through the transmitter circuit. And over here is a temperature sensor. It will detect the temperature of the wireless transfer circuit temperature, and if a temperature exceeded a threshold, it will notify error with a red LED and stop charging.
Alright, so moving on to our transmitter circuit, we see we have the leads coming in from the relay. This is what switches and allows the power to flow through our circuit. So coming here, we have a 2N2222 transistor that is biased with the 4 resistors you see here. The oscillating part of the circuit comes from this tank circuit here that you see, that's made up of 2 capacitors and 1 inductor, and then connected in series with that we have our transmitter coil, which is now has a receiver coil placed on top of it. So this configuration is called the Colpitts oscillator. It works very well at high frequency, which is what we needed for our design. And to demonstrate that for you, we have it hooked up to our power supply, our oscilloscope, and then we have our multimeter hooked up to the receiver coil to show you the power being transferred wirelessly. So to demonstrate our system, we are going to meet all the conditions of our controller, meaning the temperature has to be in the right range, and we need to have a phone or an object placed over the proximity sensor. So as you can see, our green LED lights up, meaning it has detected a device. Now we come over here to our output. We have about a volt amplitude, and then we're operating about 66 kilohertz. Now that is with a receiver coil attached, which that will lessen our frequency due to the loading effect. So then once we take our phone away, our signal is now cut off. That's to the relay. So now coming over to here, well, here's our voltage of our receiver coil. So we're reading 0 volts right now. When a phone is placed onto the proximity sensor, senses the device, and we're now reading about 0.12 millivolts on our receiver coil. And as an FYI, our system, we have it laid out pretty open right now for the full demonstration. So for one, our receiver coil would have to be right next to the proximity sensor, and our temperature sensor would be right in that range as well to give us the most accurate readings.